All right, the last example involves evaluating logarithms, and it's based on these properties of logarithms. And we have, first off, log of 1 base anything is 0. Here's why. Anything to the 0 power equals 1. Obviously, right? So this base raised to this power equals that number. So anything raised to the 0 power equals 1. Keep in mind the base of a logarithm has to be greater than 0. So it could be log of 1 base 0.2 equals 0. Log of 1 base negative 2, that's no good. It's got to be positive bases. All right. Log of anything base itself equals 1. C to the first power equals C. Again, if you look at an exponential form, it's obvious. Okay. Log of anything to a power base itself is equal to the power. Again, we already discussed that a moment ago. This number raised to that power equals that expression. They're exactly the same. And then again, just like I showed you in the last example, if you have a logarithmic exponent and the base matches the base, the argument is the answer. Those are our rules of logarithms, we'll say. There's another thing called laws of logarithms coming up down the road. But these are just evaluation rules for logarithms. And again, understood bases, if you see log, no base at all, that's log base 10. If you see ln, that's log base c. Otherwise, they'll be written out, whatever the bases are. These are the two buttons on your calculator. So it says log 50. You can type in log 50 equals to give you decimal approximation. For right now, we're going to be getting nice, pretty answers using these facts. So, example 3, we're supposed to evaluate each of these. First off, log of 1 base anything equals 0. There's no reason. I mean, there's no work to show. It's just that is what it is. All right. Log of anything base itself equals 1. Log of anything to the power base itself equals the power. Log of 2 to the 4th base 2 is equal to 4. And if you have an exponential logarithm and the base of the exponent matches the base of the argument of the expression, the argument is the answer. Okay. Know your rules, understand your rules, and be able to evaluate. One thing they might throw at you in this section, if they say, for example, let's say log base 3 of 1 over 81. Let's say they give you that. Okay. It's not log of 1, it's not log of 3, it's not log of 3 to a power, and it's not some exponential expression. What's it look more like out of those 4 possibilities? If I had to pick one of these 4, it's obviously not D, right? And it's not log of 1 or log of itself, right? So it's going to be like this, right? Yeah. So my goal then would be, I want this thing to be 3 to a power. So if I just start investigating 3, 3 times 3 is 9, times 3 is 27, times 3 is 81. 3 to the 4th is the same as 81, right? Yeah. And the fact it's 1 over 81, it means 1 over 3 to the 4th, which is 3 to the negative 4th, right? So then I can transform it into log base 3 of 3 to the negative 4th power. Once I get that proper structure, the answer is negative 4. Okay, that's the hardest type of problem I'm going to throw at you tonight. Is one that isn't already in that power structure like this, but it can be made into that. The one on your quiz that's of this variety is like that, where you get something like this, you have to transform it into this number raised to a power. It will work. It'll be exactly right, but you still have to go through the technique to figure out what the power needs to be to make that.